Okay, so this is chapter 1, solving linear equations, lesson 1.1, solving simple equations. Keyword here, guys, is simple. These equations that you're going to be solving today are very simple, okay? If you are still struggling by the time we end class, you need to come see me, okay? Because we need to talk about it. All right, let's get started. So, our objectives in this lesson, do not write this down. Do not write this down. We are going to be solving linear equations using addition and subtraction. We're also going to be solving linear equations using multiplication and division, and solving linear equations, or use linear equations to solve real life problems. Do not write down the objectives, but I do want you guys to take a note of the funny little thing that's in here. It's the Dos Equis guy, the most interesting man in the world, and he says, I don't always solve equations correctly, but when I do, it's because I checked my answer. That is a huge thing, guys. On any test or quiz, whenever you guys finish, if you have extra time, go back and check your answers. It's the easiest thing you can do. You just plug in your solution back into the original problem, and you find out whether you were right or wrong. It's like the math hack is what I call it, okay? Because you can always find out whether you're going to get 100 or not based on if you checked your answers. Okay, moving on. Any equation, this you do have to write down. Everything that is highlighted, if you don't have a highlighter, just put an underline under it, okay? If you want to make it nice and pretty and highlight it, that is up to you. An equation is a statement that two expressions are equal, okay? It basically is that equal sign that you always see in the middle of the expression, and that creates an equation. When you're setting one thing equal to another, that's what generates an equation. A linear equation is one variable, is an equation that can be written in the form ax plus b equals 0. In other words, it has a variable part, which is the x, and it has a constant part, which is the b. A solution is when you boil down your entire equation down to one single variable equals a number, okay? That is your solution. So like if we were to solve a solution or solve an equation and we got x equals 5, 5 becomes our solution. It's the value that makes the equation true. Inverse operations. Inverse operations are two operations that undo each other. For example, addition and subtraction are inverse operations, okay? Now, stop writing for just 2 seconds. If I told you that addition and subtraction are the two inverse operations, what do you think the other pair of inverse operations are? Yeah. Multiplication and division. Nailed it. Okay, keep writing. So, inverse operations include addition and subtraction, and the other pair is multiplication and division. All right? And then the last vocabulary word is equivalent expressions. Those are expressions that have the same solution, okay? So if you solve two different equations and they both give you x equals 7, those are equivalent expressions, okay? I need you to write down the addition property of equality and the subtraction property of equality. So now in your notes, I would like you to write down both of these, and then we're going to try two on our own. B, 0.9 equals y plus 2.8. What do I do first, Brayden?
You subtract 2.8.
Ah, jump the gun there, though.
Oh, you find the variable.
Find the variable, okay? Y is our variable. Agreed? It's the only letter in there. Amina, do you agree with Brayden to subtract 2.8?
Yes.
Why would we do that? What's our goal in our second step?
We're trying to cancel the math.
But cancel out what specifically?
Cancel out 0.9
That's going to cancel?
no.
Did 2.8. And if we do it to both sides, we're going to get y on the right equals, what do we got on the left? Who's good with subtraction and decimals? Joel, go for it. 1.9. If I told you this answer was just slightly off, why would it be off? Does anyone know? This answer is just a little bit wrong. Aiden?
Is it y equals 1.9?
Oh. Nope. Giovanni?
It's because the variable always has to be on the...
Nope. You can write it like this. You can write it like this. Why is this answer just slightly wrong? Aurora?
It's supposed to be negative.
Ah, why?
Because 0.9 minus 2.8, it's negative because 2.8 is bigger than 0.9.
The 2.8 is bigger. Do you guys see that? The negative 2.8 is going to overpower the positive 0.9. Okay? Now, I want you guys to try some on your own, but before we do that, tell me what property of equality we just used here. Grace? Very good. This one's subtraction. I'm going to put POE for property of equality. And finally, we didn't do one thing here. We forgot to do it for both problems. What is it? Carson?
Check our answer.
There we go. Check our answer, okay? We justified each step by putting the subtraction and the addition property of equality. We solved, but we never checked our answer, okay? So let's check the first one. Wherever I see x in the original expression, instead of x, I'm going to put negative 2 with parentheses. So we're going to write negative 2 minus 3 equals negative 5. Let's just look at the left side of the equation. Victor, what is negative 2 minus 3?
Negative 2 minus 3 would be 1.
1 equals negative 5. So either our solution's wrong or what we did on the left side is wrong. Nick, what do you think?
It's wrong.
What's wrong? The 1?
No, yeah, because when the negative is on the left side and you have a positive on the right side being subtracted, you have to change the subtraction symbol to an addition.
So you want to write it like this, negative 2 plus negative 3?
Yeah,
Okay. And what would that give you?
negative 5.
Very good. Okay. So we did have the right solution. Victor, do you see that?
Yeah.
Okay. Whenever we have something that's negative minus something else, they're the same sign, they're moving in the same direction, we're going to add their values together. Okay? All right. What about B? If we were to take 0.9 equals y plus 2.8, and we plug in for y negative 1.9, we would get 0.9 equals negative 1.9 plus 2.8. What's that right side of the expression going to simplify to? What's the right side of the equation going to simplify to? Well, let's take a look. Are they the same sign or different signs? With the 1.9 and the 2.8? They're different, okay? So we're going to subtract them. So we do 2.8 minus 1.9, okay? You put the bigger number minus the smaller number. When we subtract them, we can't do 9 minus 8, so we have to borrow from the 2. You make this 18. 18 minus 9 is 9. And then 1 minus 1 is 0. 0.9. Is it going to be positive or negative, though? Why?
Because we made the negative into a subtraction.
Brayden?
Because 2.8 is the bigger number.
Very good. 2.8 is the bigger number, and that one's positive. Do you see that, Nick?
Yeah.
Okay. So 0.9. So that means we've checked our work. Okay, I've got 2 examples on the next slide for you guys to try. But first, does that match up? Brooke? Yes. Because negative 10 plus 3 is what? Negative 7 equals negative 7. Beautiful. If you want to label this part of your work, check. That's a good idea. All right, did anyone get number 2 or think that they got number 2? Pedro, what'd you get?
I dropped.
You don't have to walk me through it. Just tell me what you got for G.
G, I added 1 over 3.
What'd you get for G, though?
Oh, I get for G, negative 1 over 3.
Hey, all right. Now that I know you got the right answer, walk me through it.
Alright, so, the variable is G, and then you add 1 to 1 over 3.
Okay.
On both sides. 3 cancel out the first one, and the next one will end up in negative 1 over 3.
So negative 2 over 3 plus 1 over 3, you're saying is negative 1 over 3. I agree with you. Who can explain other than Pedro why that is correct? Why does G equal negative 1 over 3? How does that happen? Brayden?
Because in fractions, you don't use the denominator, you don't change the denominator with addition, but on the top, the negative 2 is larger, so you keep the sign.
Correct. So this is technically just negative 2 plus 1 over 3. Whenever you have a common denominator, you can add the numerators or subtract the numerators depending on the operation, okay? And then negative 2 plus 1, they're different signs, so we're subtracting them. 2 minus 1 is going to give us 1, and we know it's negative because the 2 was the bigger number. So G equals negative 1/3. Aiden, what haven't I done that I need to do still? Check it. So let's check it, okay? When we check, we're going to plug G in for the value. So we're going to put parentheses around where G was, put minus 1 over 3 equals negative 2 over 3. And we're going to plug in the value for G that we had, which was negative 1 over 3. Negative 1 over 3 minus 1 over 3 equals negative 2 over 3. Yep. Last two. Copy down A and C. We are not going to do B. A and C, and we're done, peeps. A and C, and we're done. In A, we've got negative n divided by 5 equals negative 3. Okay? First, let's identify our variable. And in A, what is our variable, Isabella? Very good, it's n. Now, n is on the left side. What else is on the left side? There's that 5 and that negative, okay? Does anyone have any ideas of what we could do to get rid of that 5 and the negative sign? Amina?
You would have to plus 3.
Plus 3.
On the side.
But remember,
Whatever you do on that side, you have to do it on the other side.
is that 3 on the side of the n? No. So we don't want to deal with that 3 yet, okay? We want to deal with the stuff that's on the same side. Nick, what do you think?
Multiplied by negative 5.
Ooh, let's see what happens if we multiply by negative 5. Let's put parentheses around this and multiply it by negative 5. Let's put parentheses around this because just like Amina said, whatever we do to one side, we have to do to the other, or else there's no equivalence then. And multiply by negative 5. So I'm going to rewrite it because it looks a little messy right now. We've got negative 5 times negative n over 5 equals negative 3 times negative 5. All right, why do we do that? What's going to happen? Who can tell me what's going to happen on the left side of my problem?
Oh wait, no, you don't.
Brayden?
That the negative 5 and the other negative 5 are going to cancel out, and it's going to leave n by itself on the left side.
Very good. The reason we multiply by negative 5, Nick was so good, was that this 5 and this 5 will cancel. And the negatives, remember, 2 negatives multiplied together give me a positive. So we have positive n left over on the left equals, and negative 3 times negative 5, what do I get there? Victor? 15. Positive or negative, though? Positive, okay? Positive. Remember, multiplication and division properties of negative signs are different than addition and subtraction, okay? So n equals 15. This is the tricky part, what property of equality did I just use? What property of equality did I just use? Brianna? It is multiplication, okay? I appreciate that you raised your hand. Okay, this is the multiplication property of equality. And Liz, if I were to stop here, what did I not do? Yep, I didn't check, okay? So I have to take that n equals 15 and plug it back in. So we've got negative 15, wherever n was, over 5 equals negative 3. Yep. What's 15 divided by 5, peeps? 3. So negative 3 equals negative 3. Boom, bada bing. We're good. Okay, your turn. Try C. Oh, before we try C, guys, what's the variable? Z, okay? What's going on? What operation is being used between the 1.3 and the Z? Valerie? Very good. It's multiplication. That is the only operation that you may not see, okay? It's the only one that can be invisible is multiplication, all right? So if you ever don't see an operation, it's always being multiplied, all right? So there's multiplying going on between the 1.3 and the Z. How do you solve it? Go. All right, Daniela, do you know what to do? No? Jacob? Valerie, what do I do?
You would have to find a variable which is Z, and then you would have to divide 1.3, and then there'd be 1, which a variable equals 1. And then you would have to divide 5.2 by 1.3, and then it would equal 4.
Very good. Can anyone tell me, why did Valerie divide? What about this problem told you that you needed it to divide? Aya?
Because it's multiplication, and the inverse operation.
Very good. Our initial problem had multiplication, and I love that you said inverse operation. The inverse operation of that multiplication is division. So we divide by 1.3. Guys, all I want you to do, you don't have to check this one, just put that we use the division property of equality. And we're going to turn these in.